The series summation n going from 1 to infinity minus 1 the power n divided by n into mod x the power n is uniformly convergent in this given interval. So we are going to apply the Abel's test over here, and Abel's test requires three things. First, if you consider this your unx and this to be vnx, then Abel's test requires number 1, summation unx where n going from 1 to infinity is uniformly convergent. Second, to show that this vnx, this sequence is a decreasing sequence of positive terms. And third, to show that this vn sequence is uniformly bounded. If we are able to show all these three things, then we say that by Abel's test, this given series is uniformly convergent. So let's move on to the proof now. So this is your given series, and let's take this to be unx and this to be vnx. So let unx is equal to minus 1 the power n divided by n, and vnx is equal to mod of x the power n, right? First, to show that summation unx is uniformly convergent. For that, we are going to use the Leibniz test, right? Now, since in this unx, 1 divided by n, this is a decreasing sequence that is converging to 0, yes, right? And also we are having minus 1 the power n, that is, this series is alternating series. So we are going to take the help of the Leibniz test over here. So by Leibniz test, we say that this series is, that is summation unx is uniformly convergent. So writing this, since the sequence 1 by n is a decreasing sequence, converging to 0, so by Leibniz test, the alternating series summation n going from 1 to infinity un, that is equal to summation n going from 1 to infinity, writing un minus 1 the power n divided by n. This is convergent, right? And because this un is independent of x, whenever the series is independent of x, because for uniform convergence, there exists a positive integer n that depends only upon epsilon but independent of x. But in case of convergent series, that positive integer n depends on epsilon and also on the point x, right? And because this is independent of x, so we are writing that since unx, that is equal to minus 1 the power n divided by n, is independent of x, therefore summation n going from 1 to infinity unx, that is equal to summation n going from 1 to infinity minus 1 the power n divided by n is uniformly convergent, right? Please note that. To show that vns sequence is decreasing sequence of positive terms. Now what is vnx? Vnx is equal to mod of x the power n. For the given interval, minus 1 less than equal to x less than equal to 1. Now x is lying between minus 1 and 1. So clearly this vnx is a decreasing sequence, right, of positive terms, because there is a mod with x, right? So clearly sequence vnx is a decreasing sequence of positive terms on x lying between minus 1 to 1. And third, to show that sequence vnx is a uniformly bounded sequence. right? Now since mod of Vnx, this is equal to mod of x to the power n, which is less than equal to 1 for all n belonging to the natural numbers and x lying in the interval -1 to 1, right? So this confirms the boundedness of Vnx. So therefore, Vnx is uniformly bounded on closed interval -1 to 1, right? Now since Vnx is uniformly bounded and it is also a decreasing sequence of positive terms, and here summation unx is uniformly convergent, so all the three requirements of Abel's test has been proved. So by Abel's test we say that the given series is uniformly convergent. Now since summation n going from 1 to infinity unx is uniformly convergent, on closed interval -1 to 1, and Vnx is a decreasing sequence of positive terms, and is uniformly bounded on closed interval -1 to 1. So therefore, by Abel's test, the given series is that is summation n going from 1 to infinity unx into Vnx, that is equal to summation n going from 1 to infinity. What is unx? It is -1 the power n divided by n into Vnx, that is mod of x the power n, is uniformly convergent on the closed interval -1 to 1, right? Hence proved. Alright, thank you.